Okay, welcome back. This video is going to be dedicated to doing examples, working examples about that involve derivatives of exponential and logarithmic functions. Okay, so let's get started. Example 1 is to find the derivative, and we've got three different functions that we want to take the derivative for. Let's look at this first one. So for the first one we have, let me actually zoom out of here. So for the first one, we have R of W equals 4 to the W, 4 to the power of W minus 5 times log of W base 9. Okay. So for part A, we've got, for this 4 to the W, we're going to use our...
It's 1945.
Thank you. We're going to use let's see here. Let me just write our properties down. Our formulas. So d dx of a to the x is equal to natural log of a times a to the x. Remember, that's a constant. And then the second formula that we're going to need is for this log base 9. And so d dx of log base a of x is equal to 1 over x times the natural log of a. Okay, so now, actually, when we're doing a, it shouldn't be that bad. R prime of w is going to be equal to, now 4 to the w, what's the derivative of that? So d dw of 4 to the w is equal to natural log of 4 times 4 to the w. So I just want to highlight what I've done here. Instead of having x, I have w. Okay, my a is 4. So natural log of a, natural log of 4. A to the x, 4 to the w. Okay. So that's going to be the first piece we put in here, is that this r prime of w is equal to the natural log of 4 times 4 to the w. And then for the second bit, we need to know the derivative with respect to w of log of w base 9. Now here, I'm going to get 1 over w times natural log of 9. Okay, so we'll put in here minus 5 times 1 over w times the natural log of 9. Okay, so r prime of w is equal to the natural log of 4 times 4 to the power of w minus 5 over w times the natural log of 9. Okay. All right. Now let's go for B. And maybe I switch up to a different color. So for B, let's see here. Let me copy. Now go to a new page. Paste. All right, so here's my B. And now let's see here. So I know that the derivative with respect to x of e to the x is e to the x. And the derivative with respect to x of natural log of x is 1 over x. And let me actually point out here that this formula right here, what I've written is assuming that x is positive, because remember, you can't plug in a negative, you can't take the natural log of a negative number, right? So the domain of natural log function only includes positive numbers. There is an alternative version of this formula, which is that the derivative with respect to x of natural log of absolute value of x is equal to 1 over absolute value of x. Okay, so you can feel free to use both of them. For me, I am almost always, using this version right here. And I'm just restricting my domain for x. But If you feel comfortable using the absolute value, you can use that one as well. So both of them are correct. All right. So now let's go ahead and get to the solution here. All right. So when I do my derivative of 3 times e to the x, I'm going to get just 3 times e to the x. But now to do the derivative of this second part here, which is 10x cubed times natural log of x, looks like I need to use the product rule, right? Because I've got a product. So let's go ahead and move down here. So I need ddx of x cubed times natural log of x is going to equal, I need the derivative, let me actually clear some space out, is equal to, so I need the derivative with respect to x of x cubed times natural log of x plus x cubed times the derivative with respect to x of natural log of x. So this, what I'm doing right here, is using the product rule, right? So this is like my f prime g plus f g prime, right? Okay. So what's my derivative with respect to x of x cubed? I'm going to get 3x squared. So now this times natural log of x, okay, plus x cubed times, what's the derivative of natural log of x? 1 over x. So we actually have some simplifying going on, and we'll have 3x squared natural log of x plus x squared. So f prime, let me actually, just to make this clear, the derivative with respect to x of 3 e to the x plus 10x cubed natural log of x is equal to, and I'm putting it all together, so I'm going to take this 3e to the x plus, then I take this 3x squared natural log of x plus x squared. And that is my final answer. Okay, and now let's go and do C. Copy. Paste. Okay, so this is our part C, and we're supposed to find the derivative. Here, I need to use my quotient rule. Okay, so in the top here, I've got my f. This will be my f of x. And in the bottom here, this will be my g of x. Okay, so remember, f over g prime, the derivative of f divided by g, is equal to f g prime minus g f prime over g squared. Okay, so let's go ahead and start filling this in. F prime of x is going to equal 5 times e to the x, because remember the derivative of e to the x is e to the x. Now g of x is equal to 3 times e to the x plus 1. So g prime of x is equal to 3e to the x. Okay, so I just need to plug this in here. So y prime is equal to, I need f 5e to the x times g prime 3e to the x minus g 3e to the x plus 1 times f prime 5e to the x divided by g squared, which is 3 e to the x plus 1 squared. Okay? And we can simplify this to be 15e, so the 3 and the 5, 15, and then e to the x squared, which is going to be e to the 2x, minus 15 e to the 2x plus 5 e to the x, that's in parentheses, divided by 3 e to the x plus 1 quantity squared. So we'll have these canceling out, these first two terms canceling out, and we'll just get negative 5 e to the x divided by 3 e to the x plus 1 quantity squared. Okie dokie. Now, let's do another example, which is, suppose, this is going to be example 2, suppose the position of an object is given by s of t equals t e to the t. Does the object stop moving? So that's the question. And in order to answer this, we are essentially going to change this question. We're going to change it from English words into math language. And math language would be to say, is solve for t, s prime of t equals 0, right? If you can solve s prime of t equals 0, if there exists a t such that s prime of t equals 0, then the object stops moving when the derivative is equal to 0. So in fact, let me write that down on the side. So the object stops moving is the same thing, the derivative at t equals a is 0. That's the same thing as s prime of a equals 0. Okay, and let me do a little cleanup here. The object stopped moving at time t equals a is the same thing as the derivative at t equals a is 0, and that's the same thing as s prime of a is equal to 0. So that's why we're able to turn the problem into this word problem of does the object stop moving, turn it into a mathematical question, which is there a solution to s prime of t equals 0? So let's go ahead and work it out. So now s of t is equal to t times e to the t. So we need a formula for s prime of t. Well, we're going to use the product rule. You got it. And we're going to use the product rule because this is our f of t is equal to t, and g of t is equal to e to the t. So, formula, remember, fg prime is equal to f prime g plus fg prime, right? So let's just go ahead and calculate if, didn't mean to do that. So if f of t is equal to t, then f prime of t is equal to 1. If g of t is equal to e to the t, g prime of t is equal to e to the t. So we should be able to plug in these 4 back into our product rule to determine S prime of t. Okay, so let's see here. So S prime of t is going to be equal to, remember it's F, so F prime, which is going to be 1 times G, which is e to the t, plus F, which is t, times G prime, which is e to the t. So we get e to the t plus t e to the t, and we can factor out e to the t, 1 plus t, right? And we can write it as 1 plus t times e to the t. Now, are we done? No, we're not done. We need to solve.
It's 20 hours.
Thank you. We need to solve S prime of t equal to 0. So S prime of t equals 0 means 1 plus t times e to the t is equal to 0. So 1 plus t equals 0, or e to the t is equal to 0, right? Because we've got this factor and we've got this factor. Okay. E to the t is equal to 0. When is e to the t equal to 0? Never. Okay. 1 plus t equals 0. When is 1 plus t equal to 0? When t is equal to negative 1. So, if we're assuming that the position of an object is given by S of t and t corresponds to time, you could say for t equals negative 1, the object stops moving. In other words, after t equals 0, the object never stops moving. So in fact, I'm actually going to put in parentheses this first answer here, because probably there might be some physics context where you would want to look at negative time. I don't know. So for right now, probably the more reasonable answer would be to say the object never stops moving. Okay. The last thing I want to do is actually, I would like to bring your attention to something which is a mistake that a lot of students make, and I would like to help you out here and say that you want to be careful not to mix up your derivatives, of exponential functions with your derivatives of polynomials. Okay, so let me show you what I mean. Note well, the derivative with respect to x of x to the n is equal to n x to the n minus 1. But the derivative with respect to x of a to the x is equal to natural log of a times a to the x. Okay, so if you have x in the numerator, you're talking about an exponential, and you'll have a to the x. If you've got x as your base, you're talking about a polynomial, and you'll have x as your base. Okay. And lastly, I have a treat for you. I'm going to release early for you a mock midterm. Okay? And what I would like for you to do is do this at home. Do it at home. This is a treat for you. Thank you for watching the video. And what I'm saying is, here's what I'll do. I believe the videos are helpful, and so I'm putting this mock midterm, squeezing it into the video, because I think that, if you've been watching the videos, you are, um, taking time to do that and taking time to prepare yourself. So I'm trying to reward that behavior because I want more of it. I want you to study more. I want you to get prepared for the exam. So here's what you do. Do it at home. That's number one. Number two, if you want me to grade it, then just drop it. You can slip it under my door, drop it by my office, which is L230. So it's the top of it's the second floor of the library by the elevator, second floor library. And I will give you feedback so that you can see, and I mean graded, it's pretend graded, it's not for an actual grade. But that way you can get an idea of how I give partial credit. You can kind of familiarize yourself with my grading style and my exam style before the midterm. So familiarize yourself with my grading style and exam style before the midterm. Okay, so I'll give you feedback. Now the key is this is only if you watch the video. And lastly, the mock exam or the midterm, let's go to it. Here it is. It is right here. So here it is. So here's the first page. And I'm leaving it up for a few seconds for you can pause and, write it down. You can see it's out of a total of 45 points. Okay. Or you can screenshot it, whatever you want. And then this is the second page. So it's a total of 8 problems. 8 problems. And 100 minutes. So give yourself 100 minutes. So just go somewhere, a quiet place. You can use the unit circle. Okay. And good luck.